Welcome to the evolution of AI, past, present, and future. Understanding the history of artificial intelligence is crucial to grasping where AI stands today and where it's headed. Join us as we journey through the fascinating development of AI. First, let's define artificial intelligence. It's a field of computer science focused on creating systems that can replicate human intelligence and problem solving. These systems process vast amounts of data, learn from past experiences, and adapt to improve over time. Unlike traditional software, they don't always need human intervention to fix issues or enhance performance. Imagine a program that improves itself, restructuring and expanding its capabilities without constant human oversight. That's the power of AI. The concept of artificial beings isn't new. In ancient times, inventors crafted what we might call robots, power-driven mechanisms that moved independently. The very word automaton comes from ancient Greek, meaning acting of one's own will. One of the earliest records, from 400 BCE, describes an automatic dove by a friend of Plato. Centuries later, Leonardo da Vinci, around 1495, designed one of the most famous early robots, a knight that could sit up, wave its arms, and even open its visor. The early 20th century saw a surge of media exploring artificial humans. This sparked a pivotal question among scientists. Is an artificial intellect possible? Creators even built early forms of what we now call computers, though most were comparatively simple. Some were steam-powered, capable of facial expressions, and even walking. The word computer itself was coined in a Czech play in 1921, reflecting the growing fascination with mechanical brains. The true birth of AI as a field came between 1950 and 1956, a period that saw interest in AI really come to a head. In 1950, Alan Turing published Computing Machinery and Intelligence, which introduced the famous Turing test, a benchmark for measuring machine intelligence. In 1952, computer scientist Arthur Samuel developed the first computer program capable of learning to play checkers independently, a significant leap forward. Finally, in 1955, John McCarthy hosted a workshop at Dartmouth, where the term artificial intelligence was officially coined and gained widespread use. Key milestones that shaped AI between 1957 and 1987. The period from 1957 to 1979 marked the maturation of AI. It was a time of both rapid advancement and significant challenges. This era saw quick growth in AI research, but also faced struggles in terms of public perception and funding. Despite the challenges, AI quickly became a familiar concept, influencing everything from programming languages to popular culture. Let's dive into some of the pivotal moments during this maturation phase. In 1958, John McCarthy developed LISP, the first programming language specifically for AI research, which is still used today. Arthur Samuel coined the term machine learning in 1959, while discussing machines learning to play checkers better than humans. 1961 saw the first industrial robot, Unimate, begin work at General Motors, performing tasks too dangerous for humans. Edward Feigenbaum and Joshua Lederberg created the first expert system in 1965, designed to mimic human expert decision-making. In 1966, Joseph Weisbaum created ELIZA, the first chatterbot, which used natural language processing to converse with humans. Soviet mathematician Alexei Ivakanenko published Group Method of Data Handling in 1968, proposing an approach that foreshadowed profound knowledge. A 1973 report by James Lighthill led to reduced support and funding for AI research from the British government. The Stanford Cart, created by James L. Adams, successfully navigated a room full of chairs without human intervention in 1979. Also in 1979, the American Association of Artificial Intelligence, AAAI, was founded, a key organization for AI advancement. Moving into the 1980s, AI experienced a period of rapid growth and renewed interest, known as the AI thriving. This era saw an explosion of interest in AI, driven by both research breakthroughs and increased government funding. Advances in research, particularly in deep learning and expert systems, coupled with significant government funding, fueled this boom. Deep learning techniques and the use of expert systems became more popular, allowing computers to learn from mistakes and make autonomous decisions. Let's highlight some key events during this thriving period. The first conference of the AAAI was held at Stanford in 1980, marking a significant gathering for AI researchers. XCon, the first commercial expert system, launched in 1980, assisting in configuring computer systems based on customer needs. In 1981, the Japanese government invested heavily in the fifth-generation computer project, aiming for human-level AI capabilities. Despite the boom, the AAAI warned in 1984 of an incoming AI winter, foreseeing a decline in capital and interest. From early foundational ideas to periods of boom and bust, the maturation and thriving of AI laid the groundwork for the intelligent systems we see today. AI winter, a time when enthusiasm for AI significantly cooled. The AAAI, or Association for the Advancement of Artificial Intelligence, had indeed warned about its coming. This term describes a period of low consumer, public, and private interest in AI, leading to reduced research funding and, consequently, few technological advances. But what caused this downturn in AI development? A major factor was setbacks in the machine market and expert systems, including the end of the fifth-generation project. There were also significant reductions in strategic computing initiatives and a slowdown in the deployment of expert systems. Let's look at some notable events during this AI winter. In 1987, the market for specialized LISP-based hardware collapsed due to cheaper and more accessible competitors from companies like IBM and Apple. Then, in 1988, programmer Rollo Carpenter invented the chatbot Jabberwocky, designed for engaging human conversation. Fast forward to 2012, and we enter the era of artificial general intelligence, continuing to the present day. This period has seen a massive surge in common-use AI tools, from virtual assistants to advanced search engines. This era also popularized the concepts of deep learning and big data, fueling incredible advancements. Let's highlight some of the outstanding dates and achievements in this recent period. In 2012, Google researchers Jeff Dean and Andrew Ng trained a neural network to recognize cats from unlabeled images without any prior context. 2015 saw Elon Musk, Stephen Hawking, Steve Wozniak, and over 3,000 others sign an open letter calling for the prescription of autonomous weapons. In 2016, Hanson Robotics created Sophia, the first robot citizen, known for her realistic appearance, ability to replicate emotions, and communication skills. Remarkably, in 2017, Facebook programmed 2 AI chatbots that, while negotiating, autonomously developed their own language, abandoning English. The following year, 2018, Alibaba's language processing AI surpassed human intellect on a Stanford reading and comprehension test. In 2019, Google's AlphaStar achieved Grandmaster status in the video game StarCraft II, outperforming all but 0.2% of human players. 2020 marked a major milestone as OpenAI began beta testing GPT-3, a deep learning model capable of creating human-like code, poetry, and other text. And in 2021, OpenAI developed DALL-E, an AI that can process and understand images to produce precise descriptions, bringing AI closer to understanding the visual world. From the quiet of the AI winter to the explosive growth of today, the journey of AI has been extraordinary. The rapid advancements continue, promising an even more integrated and intelligent future. Aspects of AI that could affect us negatively, from fairness issues to job displacement and even new forms of threats. This content is for anyone interested in the broader societal implications of AI, offering a balanced perspective beyond the hype. By understanding these potential pitfalls, we can work towards more responsible AI development and a more prepared future. First, let's talk about AI unfairness. Since AI systems are built by humans, they can inadvertently carry built-in biases, whether those are introduced deliberately or carelessly. If AI procedures are designed with a bias, or if the data they learn from is biased, they will produce unfair results. We've already seen examples like prejudiced recruiting algorithms. Another instance is Microsoft's Twitter chatbot, which quickly became bigoted after interacting with real-world, unfiltered data. This highlights the critical need for responsible development and training. Next, the loss of certain jobs. While AI is expected to create many new opportunities, some existing roles will inevitably be taken over by machines. This shift will necessitate significant changes to training and education programs to prepare our future workforce for new AI-integrated roles. It also means helping current employees transition into new positions that leverage their unique human abilities, rather than competing with AI. A profound change in human experience could also occur. If AI handles tedious tasks, giving humans more free time, this newfound liberty might initially seem ideal. However, to maintain a sense of purpose, humans will need to channel this freedom into new activities that provide the social and mental fulfillment jobs once offered. There will also be financial implications when machines take over tasks that humans used to get paid to do. While businesses might see clear economic benefits, the overall societal impact is less clear. AI also raises the stakes for enhanced hacking. AI significantly increases the speed of malicious acts, often exceeding our human ability to keep up. Robotic, despicable acts like advanced phishing schemes, rapid virus delivery to software, and exploiting AI systems themselves could become common. It might become incredibly difficult for humans to detect these problems until they manifest as a major, real-world issue. Furthermore, we may face new AI-enabled forms of terrorism and intimidation. This could range from an increase in independent drones and the introduction of autonomous robotic groups used for malicious purposes, or even remote attacks and the delivery of diseases through nanorobots. Law enforcement and defense organizations will need to adapt rapidly. In conclusion, while we can never entirely predict the future, many leading experts are discussing these possible negative futures of AI, allowing us to make refined presumptions. Company leaders won't have to spend time sifting through data themselves, but instead can use instant AI-driven insights to make informed, proactive choices.